Despite the long development of the graphical user interface, working with aggregate selections of multiple objects still remains a challenge. This is due to the difficulty of forming complex selections, ambiguities of operations, and the need for tedious repetitive cycles to unselect, reselect, or ungroup, regroup objects. To date, significant research has focused on improving the efficiency of selection, while largely failing to address the larger workflow challenges. We introduce collection objects. Collection objects unifies selection, grouping, and manipulation of aggregate selections into a single object, which enables fluid formation and manipulation of aggregate selections. Collection objects encapsulate various selection techniques, as well as afford new ones using a set of filter attributes, located on the top corner of the diamond. A user can lasso select the whole of the bunny's head. Holding a finger on the canvas creates a collection object. She can hold the collection object to put the system into a quasi-mode and carefully lasso around the head. But if she accidentally selects drawing objects she doesn't want, she will need to manually remove them. Alternatively, she can simply open the attribute stack of the outline of the head and copy its shape into a collection object. Immediately, everything within the shape is selected. Other attributes may also be reused by collection object to enable selection by attributes. For example, a user can select all the stars in the sky by copying the geometry attribute into the collection object. A user may select the star individually without caring about its attributes. As the user adds objects, our tool will suggest the common attributes as possible criteria. A single tap on the potential attribute adds it to the collection, and will expand the scope to include all objects with the same attribute value. In this heat map example, the user may wish to separate the extreme colors from the drawing. She can first select all the objects by using the darkest and lightest colors as filters. When the attribute object is inserted into the collection object, a fuzziness meta attribute is automatically added to it, and can be edited to select objects with similar but not the identical attributes. In this design of an Easter egg, a user wants to select all the red petals in the Easter egg on the top. She can start to select using a red fill color attribute. However, this also selects the red objects in other eggs. She can constrain the selection within the top Easter egg by using its shape as a boundary. After making the changes, she can easily flip the boundary to invert the filter condition and switch her attention to the other objects with that fill color. In addition to the attributes that define the selection, collection objects also include an aggregation of the attributes of the selected object to enable fluid manipulations of the selection. When a user first opens a collection object, an iconic representation for each of its object attributes is shown on the card. A vertical pinch gesture on the card reveals a useful aggregate of the attributes, which enables the user to explore the various relationships of attributes within the collection. If the user continues to expand beyond this aggregate view, the complete set of values is shown, which allows the user to share a particular value within the set. Objects inside the collection can be collectively manipulated. For example, while holding the stroke attribute, landing and moving a second finger on the canvas changes the stroke width of all objects in the collection. If she lands her finger on a particular object, only that object's stroke width will be changed. The quasi-mode associated with the landing object allows the user to quickly adjust the manipulation of individual objects, or the collection of objects, without switching between single selection and multi-selection. A common use of multi-selection is to apply the same attribute to all the selected objects. With collection objects, this can be trivially achieved by holding the attribute of the selected objects, and then tapping on any other object to retrieve its attribute. To achieve the same result in a traditional application, a user would have to switch focus to another object, look up and copy its value, reselect the objects, and finally apply the change. Objects within a collection can be grouped with a hierarchical structure to manage complex drawings. A vertical flip on the collection object transforms the selected objects into a group. A single tap of an object opens the collection object card of the group at its highest level. A user can then hold the individual object she wants to navigate to and drag the diamond card. Immediately after touching the diamond card, levels associated with the held object appear underneath the finger, through which the user can navigate to different levels by dragging the card. Alternatively, the user can hold the object and drag another finger on the canvas to quickly navigate to the desired group. Groups with collection object maintain an open structure so that objects within different groups can be selected. A single tap on the object selects the group it belongs to. However, if the user wishes to quickly select individual objects, they can touch down on the object, drag down to navigate to the desired level, and release their finger to select it. As she becomes familiar, she can quickly select the objects by swiping down. We have presented collection objects, a novel technique for manipulating collections of objects in a vector drawing application. The unification of selection, grouping, and manipulation of aggregate attributes enables quick, flexible, and fluid interaction with multiple objects.